And we have the valiant Noah Petro from, is it Goddard?
Yep.
Okay, good.
So when I was here in January for the Lunar Landed Mission Workshop for sites for future landed missions, we did Find the LEM descent stage game, everyone's favorite play-at-home game. This is a beautiful, well, in my opinion, a beautiful oblique image from LROC taken several months ago of course, the Taurus Littrow Valley. This is an easy one. Everyone can see where the descent stage is, right? Everybody have a chance, take a look. I'm going to zoom in. There is the blast zone. The little bright or dark spot in the middle there is the shadow of the descent stage. It's still sitting on the surface today. You might notice another interesting spot. There's a bright little pixel right there. That is a piece of, I guess, mylar insulation that blew off LEM during ascent. If you go back and watch the 16 millimeter ascent footage taken out of the window, you'll see stuff flying everywhere, including a piece of foil that lands right there in between the LEM and Camelot crater. So just as a reminder, though, this is the full extent, and this was a featured image a couple weeks ago on the LROC page. It's just stunning. It's a high sun image. You get really beautiful changes in albedo, including the two landslides off of the North Massif. The younger one, which is the brighter albedo feature, and the older, darker one as well, just to the east of the lighter one. Okay, so let's look at some other pictures of the moon. This was last night. Brian Day mentioned my love of baseball. This is at the San Jose Giants game, and this is where the moon is a fair ball, of course, passing over the fence. And just to remind everyone, and this point has been made a number of times, that the outreach potential for talking about the moon is pretty great. Unsolicited during what's known as the beer batter of the game, and it's a long story, and I'll explain what that means later on, over aforementioned beer. Someone sitting behind me rather loudly yelled out, "That's one small step for a man, one giant leap for beer kind." Totally unsolicited, I might add. So we're surrounded by people who may even not know how nostalgic they are for the Apollo era. I also want to show one more image, and this is a bit of a, not necessarily a correction. I've seen this image now, I think 2 or 3 times already today, without acknowledging the hard work of the person who made it, and that's Ernie Wright, who's in the Scientific Visualization Studio at NASA Goddard. He's part of the outreach and communication team for LRO, and his hard work appears on the cover of Transformative Lunar Science, the Survey Annual Report, and so I just wanted to give him a shout out, as it were, because his work appears everywhere. Amongst the LRO communications team, we have an informal, and when I mean informal, I mean totally in words only informal, drinking game. Every time we see one of Ernie Wright's works anywhere, you have to take a drink. So I haven't started that game yet, but I'm going to need a designated driver tonight. Okay, so let's talk about LRO. LRO has been at the moon now for over 9 years. We just celebrated the 9th anniversary of our launch last week, and on the 23rd, the celebration of being in lunar orbit now for over 9 years. It's a truly remarkable accomplishment, and I hope to share some of the reasons why I feel that's a major accomplishment over the course of the next few minutes. And of course, we've been at the moon now for over 9 years, but that doesn't mean we're resting on our laurels. We're preparing for many more years to come at lunar orbit. We have several hurdles, though. So first and foremost, on July 27th, there's a lunar eclipse, a relatively long one, because LRO is a solar-powered spacecraft. Going through several hours with no direct sunlight is a challenge. Now, we've survived many lunar eclipses before, and we fully anticipate that we'll survive this one. But these are very important events in the life of a lunar orbiting mission, and so we take it obviously very seriously. It's nowhere near as spectacular an event for the folks on the East Coast or in the U.S. This eclipse will not be visible from the U.S., but I use the image on the right to highlight another event that we talked about a year ago at this forum, which was the eclipse, the solar eclipse from August 21st of last year. And I think it was Jack at that meeting last year who asked how many cell phone flashlights would you have to point up to be visible in the LROC image. And we didn't get to do that experiment, unfortunately, but you'll notice there are several bright dots out in the western United States. Those are the snow-capped mountains of the Cascades. So here's a little bit of a data point for what it takes to be visible from the moon. So it's not quite a weather satellite, but it certainly could serve as one in a pinch. We just completed our 34th PDS delivery from all 7 instruments, and this is an important note for the users of LRO data. LROC is now going to be going to a monthly data delivery cycle. That helps just essentially reduce the sheer volume that goes out every 3 months historically, so they'll be delivering now every month. We are essentially at the level now where we've delivered 1 petabyte of data to the PDS, more than doubling the total volume of PDS data available to the world. Just as a frame of reference, 1 petabyte, if it were, and this is according to Wikipedia, so it must be true, if 1 petabyte were of 1 petabyte of MP3 sound files would play for about 2 millennia, 2,000 years. That's 2,000 years of music. So, you know, that's a lot of Beatles music to listen to. The LRO team has evolved. We welcome now 32 new co-Is across all of the 7 instruments. That serves to either replace people who have rotated off of LRO or left the mission for other reasons. This brings a great deal of new diversity, not just in terms of background, but also in terms of experience. Several teams welcome new leadership. Lynn Carter is the deputy PI for Mini-RF, and Brett Denevi is the deputy PI for LROC. Maria Banks is now our PDS lead. We have a new project scientist, thankfully. For me, thankfully. John's done a great job, and he's going to serve as my deputy now. And also, on July 9th, we're going to be welcoming a new mission director to LRO. So the 9 years of LRO has seen lots of continuity, but also some opportunities for change as well. Now, LRO has been a long-lived mission. And what are the benefits of being a long-lived mission? I think one of the things that's been truly remarkable about our 9 years is that we've ushered in this new era of lunar exploration. The moon has gone from a static object, and we've known that there's been changes on the moon. We've either seen flashes on the lunar surface, measured moonquakes due to impacts during the ALSEP era, but now we can actually see new impact craters that have formed on the lunar surface and observe their effects. You know, whether it's a 10-meter diameter crater with ejecta that strews out tens of kilometers away, or even larger craters and, you know, their regional effects on the regolith. As Jody will point out with the presentation on the crater instrument, which by the way has nothing to do with impact craters, it's a radiation detector. You know, this is a very unusual phase of solar activity, and so having a radiation detector in lunar orbit gives us an opportunity to understand what the impact of this very quiet period of solar activity with enhanced GCRs, what it means at the moon. Now you'll notice on the right-hand picture, this is maybe not, you look, what's wrong? Is it late in the day and my eyes are crossing? No, this is, again, another benefit of being at the moon for 9 years. So LROC, as it always does, is imaging the moon when we can. And during one scan, something happened to the left narrow angle cameras, the left and the right. Well, it turns out that the hypothesis is that during this image collect, a small meteorite struck the radiator for LROC. Now, just we would not have detected this, an object on our spacecraft. It's possible that others have happened where we haven't been imaging, but you know, I think there's a real engineering value in understanding what's happening in deep space over 9 years. I don't want to talk about the end of LRO, but boy, wouldn't it be great to send an astronaut to find out what the spacecraft looks like after 15 years orbiting the moon? I think that would be a really interesting opportunity. As much as Apollo 12 sampled Surveyor 3, why not understand what happens to an object in deep space? And that also serves as a reminder that, you know, we're operating in a very hostile environment. Not only do we get hit periodically by objects, but we're constantly being baked in the sun, soaked in radiation, and ultimately all of the hardware that operates the spacecraft, you know, gimbals our antenna, moves the solar array, are operating as if they were new. We see no appreciable degradation in the exterior of the spacecraft. Now remember, LRO has the 5 Ps of the mission. And Barbara, this is an actual launch as opposed to the animation that we saw earlier on. the 5 Ps of LRO: proposals, publications, propellant, power, and pointing. And it's that last one perhaps that will be most important to focus on, because there's going to be there are some changes to LRO going on now. As much as the launch video is beautiful, we're going to go into the 5 Ps. Proposals. So we've been fortunate that NASA is now moving to a 3-year cadence for the senior review cycle. Our next extended mission proposal, ESM-4, we anticipate a due date of April of next year. It'll be a 3-year proposal to continue LRO through September of 2021. We're proposing the full complement of 7 instruments, integrated science across all 7 science teams. One of the areas of new interest, of course, is how LRO can support this new lunar initiative, including supporting the commercial landed opportunities. And one of the areas that we anticipate is not just finding new landing sites, but also assessing what happens with these landers. So, as much as we've seen the pictures of the Apollo 17 landing site with the blast zone that Ryan can talk about at great length, we can also see what happens if things don't go well. This is Luna 23. And this is, again, a NAC image showing the landed spacecraft tipped on its side. It took LRO imaging the Luna 23 landing site for us to figure out why it didn't work when it tipped over. So we can assess not only what happens in events where the landing is successful, and we have a rover perhaps that trundles off, but also what happens if things don't go as we planned, if there is indeed litho breaking and a new crater is formed, which we don't want to have happen, but we'll certainly be there to be able to assess that. The other P, publications. LRO Science Team continues to remain incredibly productive. There's not only the 3 volumes of the Icarus special issue on LRO, we also had a special issue in Planetary and Space Sciences that was led by Mark Robinson. We had 17 papers from both LRO and non-LRO authors. Sometime in the past year, the science community has overtaken the LRO Science Team in number of publications using LRO data, which is exactly what we want to see. We want to see the science community continue to use our data that we put into the PDS. There's a number of special sessions coming up both at GSA, and I highlight just a few of them, and at AGU, and those abstract deadlines are coming up, so please stay tuned and please consider putting in your abstracts to those sessions. And again, please publish with LRO data, and when you do, just make sure you acknowledge the use of LRO data in there so we can track it very easily. Okay, so our propellant is good. We've been in a quasi-stable orbit now for several years. The large figure is an orbit history plot, and you can see that there was the roughly 2 years of time at about a 50-kilometer circular orbit. In 2012, we went into this highly elliptical but stable orbit, and several years ago, we decided to no longer do maintenance burns to keep in a relatively elliptical orbit. We are putting Sir Isaac Newton in the driver's seat and letting the orbit evolve. This allows us to conserve fuel to not only unload momentum, but also to optimize orbit for potential coincident science opportunities, observations of landings, and other events. We are observing a degradation in the solar panels, but that's as predicted and does not at this point present any issues for the spacecraft. Basically, the solar panels in LRO were larger than we needed, so we're generating ample power when we need it. At this point, if we continued in a no maintenance burns per year, but did continue to use our fuel for momentum, we have 9 years of fuel remaining on the spacecraft. But at this point, the fuel is probably not the limiting factor. I'm going to talk about pointing for a moment. The video at right shows the integration of our 2 star trackers on the spacecraft, and perhaps right now no more important event in LRO's design and development came than using those star trackers. Historically, we've used the star trackers as well as an internal measurement unit to determine where we're pointing. The internal measurement unit, momentum unit, uses a laser to help determine the rate at which LRO is moving. And like all of the systems in LRO, we monitor all of the degradation in those systems very closely. Late last year, we noticed that the intensity of that laser was in decline. It had a finite lifetime. And so basically at the end of March, just after I took over as project scientist, we went into a new mode of operations for a short period of time where we stopped doing slews, basically. This is a text from a press release we put out. But basically, since March, we've remained nadir pointing, which is essentially what LRO was designed to do. And so what we've done is stay in nadir mode while the engineers have designed a new mode of operations for us to be able to return to making off-nadir observations, similar to the LRO image that I showed before, which requires a spacecraft to look off to the side. So basically, starting hopefully in the fall, we'll be able to get back to off-nadir observations. We fully anticipate being able to do that, and we'll preserve the remaining 600 hours of expected lifetime in this inertial measurement unit for things like eclipses and delta H maneuvers and other engineering events that we want to preserve the life of that instrument for. So that's been a recent change to the sort of the standard operating procedure, but science continues on LRO. In nadir observation or nadir-only observations, Mini-RF has designed a new mode of observation, basically a mapping bistatic mode where they take targets of opportunity. Instead of pointing Mini-RF at a specific feature, they get what's below them. This is an example from June 11th of a collect that Mini-RF took. So this new mode isn't devastating for science, it just focuses us on a different mode of operations. We're looking forward to supporting future commercial landed opportunities in both assessment and post-landing characterization. That's something that we should be able to do, and especially when we're able to get back to off-nadir observations. Looking forward to supporting not just commercial landers, but of course the upcoming Chandrayaan-2 landing early next year. This was an assessment that John Keller led for a potential December landing. We know that launch and landing date has slipped, but we are eager to continue our collaboration with ISRO at maximizing the science return from that landing and mission. And lastly, just a few upcoming events. October 20th is the International Observe the Moon Night. More information is available at the website there. We help out maintain the NASA Moon Twitter account, so any lunar news, activities are going on, please let us know. We can share that with the world. And of course, next year at this time, we'll be deep in Apollo 50th anniversary celebrations. We heard today that the meeting, the forum will take place the few days after July 20th. You should note that July 24th is perhaps as important an anniversary as the landing, as that completed the actual mission with the return to the Earth. And so we should look forward to not only engaging with each other in this anniversary, but with the rest of the world and get everybody on board and excited with not just what we've done, but what's left to come. And with that, we'll go into the discussion session.
Thank you, Noah.